Alright, since you probably were focused on test 2, let's go back and do a quick review. This will now help you for test 3. We're talking about gases. The first thing you should know about a gas is how to measure pressure. And pressure is measured with a gauge or a meter, and there's different scales. The first one is millimeters of mercury. And this will be on important information, but you should know how to use it. 1 millimeter of mercury equals 1 torr. And torr is named in honor of the great Italian scientist Torricelli, who did a lot of impressive work with gases. Now, an important definition about pressure is atmospheres. And by definition, 1 atmosphere equals 760 torr equals 760 millimeters of mercury. And I'll write it again on the board. We went through this, but I'd like to go through it again. Now that you can focus on it, not material for test 2. And you should know, but this will be given to you. At sea level, 1 atmosphere is defined as 760 torr, and also since 1 torr equals 1 millimeter of mercury, that's also 760 millimeters of mercury. And the question would be, how many torr is 5.671 atmospheres? What are we given? Well, you look at there and we say 5.671 atmospheres. What are we being asked to find? How many torr? And now, what do we use? Good buddy, our good friend, we're not done with that. You'll be using the whole semester unit analysis. I only have one thing to start with. If I could use a ratio to get to where I'm trying to go, what units am I trying to get to? Torr. And now, and this is the important part, whatever I'm trying to get to goes on top. This way you don't have to memorize all these different rules, which goes here or there. You use your good buddy, your good friend unit analysis. Whatever I'm trying to get rid of goes here. And where do I get these numbers? From here. Remember, when you have two things equal each other, you have two ratios. And here I have a ratio between torr and atmospheres, and therefore I know 1 atmosphere is 760 torr. These are exact numbers because they're part of a definition. They play no role in significant figures. apologize, I should have put it in scientific notation. If you look at 4, this is what your calculator gives you. Notice this is 4 significant exact numbers. Round that off to 4. Keep the 4, keep the 3, keep the 0, keep the 9. Is that number I'm using to round off 5 or higher? It is. This adds 1, 2 becomes 10, which I have 1 here, 0 there. So the correct answer is 4.310 times 10 to the third torr. Now, everybody pay attention. This was a common mistake I saw in test 2 using unit analysis. Somebody would write this, not with this, but similar in terms of units. Which is wrong. How can you tell it's wrong? Forget about the numbers. This is where unit analysis helps you again. If you were to write that down, what would be the actual units of the answer? Well, you look at this. I have atmospheres times atmospheres. Divided by torr. Is that the answer unit-wise I want? No. But if I look up here, let's do the same thing. I'll multiply atmospheres times torr divided by torr. And notice you have torr divided by torr. Anything divided by itself becomes the number 1. 1 times anything is to whatever you multiply it, which would be ATM. So this is where you should do an extra check using unit analysis. A number of you in test 2 didn't. For test 3, it still holds true. Check that your units cancel out. Just don't assume they do. Actually, in your head, you don't have to write it down, but make sure that happens. All right. And why don't you try this one for your fun and enjoyment on this beautiful Monday. Isn't it amazing how we went right from summer to winter? Hope you all didn't blink and miss fall. If you're doing that, I need a refill. Success, I'm good for another hour. No. All right, let's take a look at this. And again, use unit analysis. First, look at the problem. What are you being asked to find? How many atmospheres O2. What are you given? And now I'll use unit analysis. Whatever I'm given, I'll put and start out with. That's all I have to work with. What units am I trying to get to in my answer? And right here, we took the time to figure out it's atmospheres of O2. And now, if I could do this conversion in one step, remember, I think you all know how to do this. If I say, quick, go out and get me 24 eggs, and you know there are 12 eggs to a dozen, you can do a ratio and find out Dr. White needs 2 dozen eggs. Well, the same thing here. If I want to go from there to there, what ratio? Well, where do I get those numbers? I use unit analysis. Whatever I'm trying to get to, I'll put on top. Whatever units I'm trying to get rid of, I'll put underneath. And where do we have a relationship between torr and atmosphere? Right here. 1 atmosphere equals 760 torr. So whenever you have 2 things equal to each other, you can put in ratios. For every 1 atmosphere, how many torr? 760. Now, before I pick up my calculator, I'll check that I set this up right. Torr times atmospheres divided by torr. Does the torr divided by torr cancel out? And the answer is yes. So this cancels out, and I'm left with the right units. And now I'll go to my calculator. Let's use this one. And this is what my calculator gives me. On test 3, like test number 2 and 1, it will say, please use proper significant figures for all calculated answers. 3 significant figures, exact numbers. My answer should be, I'll give you 3 seconds to round that off to 3 significant figures. Slow clock. 3. And therefore, keep the 4. Keep the 3. 0 is my third one. 9 is used to, wrong number. Teach me not to delete things. Keep the 1, keep the 1, keep the 1. The 1 to round off is still a 9 in this number. Is that 5 or higher? Yes. Increase the 1 in front to 2. And that's the answer you get. And this is a skill you should have for test number 3. And also, just chemists working with gases, it's a skill we need to know. Let's continue on. Just for your own edification, this switches off on this slide. There are other units of pressure measurement. You have inches of mercury, or for those of you who own a car or have ever checked the pressure in your car tires, you have inches of pounds per square inch is a measure. 1 atmosphere equals 14.7. Most of your car tires are a little more than 2 atmospheres of pressure. But you didn't think about gases in your car tire. Well, it's important. And we did this, some of these. All right, let's look at Boyle's law. I did one before, but now that you're through with test 2, let's go back and look at this. Boyle's law, and don't worry about the English part at the top. That's just there to confuse you. No, not really. It's the actual way it was stated. But mathematically, Boyle's law is P1 times V1 equals P2 times V2. It's that constant temperature. And P1 is the initial pressure. V1 is the initial volume. And P2 is the final pressure. Let's spell it. And V2 equals final volume. And this is Boyle's law. And as I mentioned earlier, these laws were developed to help understand gases in various situations. The most important is in the cylinder. Why? Because the steam engine and the combustion or gas engine help provide energy for the Industrial Revolution. And Boyle was in England about the time of that happening, and this was an important discovery. Now, law means it's always true. Let's look at a problem. Let's look at the following. 8 or 10 points for those who have mastered it, I'll decode it for you. And that is if a piston, and you know, like a piston in your car engine, has a pressure of 750 torr at 25.6 liters, liters is a measure of volume, then what is the pressure of the piston if the volume is decreased to 1.01 liters? Now, let's take the time to figure out what are we being asked to find and what are we given. And if we look at this, we say a piston has a pressure of this and this. What is the pressure if the volume is changed? And that's P2, the final pressure we're trying to find. What are we given? It has a pressure, that's P1, of 751 torr. That's the initial pressure. What's the initial volume? V1. 25.6 liters. And we're trying to find P2, and notice if the volume is decreased, changed to a new number, 1.01 liters, that's V2. And let's go through this again so you understand how I did it. It's important that you be able to do it. And I look at what am I being asked to find? What's the final pressure? Because you start out with an initial pressure and volume. Here's my initial pressure, L, liters is volume. And if the volume is decreased to my final volume. So now I notice, once I've done this, I don't have to look at this again. My life is a lot easier on the test and in real life. And now I'm trying to find P2. Notice those are only dealing with pressure and volume. As soon as you see that, Boyle's law. On test 3, in important information, you'll be given this, 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 and this. And now I know I have to start with this. And now everybody relax, take a deep breath. I'm going to do some algebra. And what am I trying to solve for? P2. I want it alone on one side. How do I do that? Well, I've got to get rid of V2. When you have two things multiplying and you want to get rid of B, well, I'll divide by B. That gives me A. Well, whatever you do to one side, you have to do to both sides. And now V2 divided by V2 becomes the number 1. And therefore I can rewrite this like that. I like to switch it around. You don't have to, but I will. And I now have that, and that's how you solve it. Let's go through what I did. I know I have to use Boyle's law because I only have variables that deal with pressure and volume, which is what Boyle's law deals with. I want to solve for P2, so I need it alone on one side. I'll divide by V2 to get rid of it, but whatever I do to one side, I do to the other. Do the math, come up here. I just like to switch it around. Now, since I've taken the time, I can put 751 torr for P1. V1 is 25.6 liters, and V2 is 1.1 liter. And before I pick up my calculator, I'll use my good buddy, my good friend, unit analysis. I'm still going for Guinness Book of World Record, most times saying that, and I think I'll get it. But torr times liters divided by liters. Liters over liters becomes the number 1. What units am I left with? Torr. That's a unit of pressure, so I'm in the right track. And now I'll go get my calculator. And the number I get is 1.90352, whatever, times 10 to the 4th. And 3 significant 3, 3, round that off to 3. If I didn't use scientific notation, notice that's roughly 19,000 torr. I started with 750. That's a giant pressure increase. Now, one of the questions you should be asking yourself in my class, always, if you don't know the answer, ask me. Why am I learning this stuff? Well, the first answer is someone said you have to take this class to get in a program or get a degree. But why learn chemistry? Well, let's take a look at this. What do we have here? Oh, warning, it's time to see some Dr. White artwork. You can laugh, it's allowed. Actually, this is pretty good. I have a cylinder, a piston, and I take at a certain volume, let's call this V1, and it's at P1. If I go and push it down to a new volume, V2, what happens to P2? Well, it dramatically increases. Why is this important? Well, think about it. We use this in our daily life. How many of you have ever inflated a bicycle tire, a car tire, a beach ball, volleyball, football? And what do you use for everything but your car tire? A hand pump. And how does a hand pump work? It's this. You pull in some air, it's got a valve at the bottom, and then when you push forward, the valve compresses the gas, that's why it's called a compressor at the gas station, and increases the pressure so you can fill up the ball or football, soccer ball, your car, or bicycle tire to a pressure higher than it is now. Now, when you go into the gas station or wherever you have get your air for your car tires, they have what's called a compressor. And a compressor is this cylinder with an electric motor that goes to a higher pressure than your bicycle pump. And it goes like this, pulls the air in, compresses it, puts it in your tire, does it again, and that's how you get a high pressure for your tire. And that all works because of Boyle's law, and that's how they were able to discover that. Now why don't you try this one out? And the question is, if a cylinder has a pressure of 652 torr and 2.56 liters, then what is the volume of the cylinder if the pressure is reduced to 253 torr? Let's do it stepwise. Why don't you first read that and find out what are you being tried to find or asked to find, and next, what are you given? Let's do that first. I'll give you a whole 90 seconds. Go. Remember, I'm not asking you to solve the problem yet. Let's figure out what are you given, what are you being asked to find. If you came in late, don't forget at the end of class, don't forget to sign in. All right, everybody have the variables done? Let's do, I'll give you another bonus 35 seconds. Remember, the clock is ticking, now I can't hear it. Anyways, that looks like it's electronic, so it won't tick. Minus 3 seconds. All right, let's do this. Everybody, take a look here. The first question you should answer is, what are you being asked to find? And the question is, what is the volume of the cylinder if the pressure is changed? And therefore, the final volume you're being asked to find is V2. What are you given? The initial pressure, P1, equals 650 torr. V1 equals 2.56 liters. And the final pressure, when the pressure is reduced, you start at something, you're going to go to P2, is 253 torr. And notice you only have volume and pressure, Boyle's law. Getting ahead of myself. Why don't you just with this variables, not with the actual numbers, solve for V2. Try that. How many of you have already done this? Raise your hand. You people didn't follow Dr. White's advice. You got ahead. For those who didn't, I'll give you a minute or so. Solve for V2. I better make an appointment. It's about that time to get my flu shot. 2 years ago I didn't, and I got really sick. So don't forget your flu shot. All right, let's do this. What are we trying to find? V2. How do we get it alone? I need to get rid of P2. When two things are multiplied, divide by the one you want to get rid of. Whatever you do to one side, you have to do to the other side. This cancels out. It's left with V2 equals P1 times V1 over P2. I'll rewrite it. You don't have to, but Dr. White does. Good habits I don't change. And now, since I took the time to figure this out, I can just go ahead and put this in, and I'll say P1, 652 torr, V1, 2.56 liters, P2, 253 torr. And now, before I pick up my calculator, I'll use unit analysis again, and I'll check to see, do I get the right units? And here, notice, torr divided by torr, anything divided by itself becomes the number 1, and therefore this cancels out. I'm left with liters. I'm trying to get the volume. It's a unit of measure for volume, so I'm on the right track. Now I'll pick up my calculator. And notice the answer I get is 6.52000, 3 significant, 3, 3. The answer will be 6.52 liters. So notice what happened when I decreased the pressure, pulling the cylinder out, the volume increased. And that, did I make a math here? Which one?
You divided it by 256 when you're supposed to divide by 253.
Thank you. Well, there goes my first score for today. And therefore, 3 significant figures. That'd be 5.60 liters. Thank you, Tiffany. Hold on 1 second. Add Dr. White. And that's how you use Boyle's law. I'd highly recommend practicing the problem. I've still got 5 minutes. Hang in there. We've done our practice time. All right. Have everybody's attention. click. Charles' law will not be on the test or the final, but I still want to briefly talk about it. And Charles' law deals with volume and temperature. And the volume of a sample of a gas is directly proportional to its Kelvin temperature. In gas laws, you never use Celsius centigrade. You always use Kelvin, otherwise it won't work if the pressure is kept constant. And Charles' law is V1 over T1 equals V2 over T2. And hold on a second while I get rid of a little blue line that shouldn't be there. And that's Charles' law. Now, if I were to ask you to find, I give you initial volume, V1, initial temperature, T1, initial volume, V2, how do you solve for T2? I know the algebra at this level, and even for 1211 here, which I have taught, most students can't. They just have trouble. So I finally decided, guess what? I'm not going to put this on the test, because most students, the algebra is quite challenging for them. So remember, the temperature is always in Kelvin. And it's even written on the slide, so you know Dr. White's not lying to you. It won't be on test or final. All right, let's talk a little about something you're all familiar with, and that is switches on, but not for definition. You'll see Wednesday, but I'll get into it today. Time for more Dr. White's artwork. Actually, this is pretty good. If you have a beaker of water and you have a Bunsen burner under it, something that heats it up, what will happen? You'll see boiling. And boiling actually deals with gases. And I'll talk about things that are not in your textbook, but I think it's important for you to learn about this. Now, when we talk about liquids, and switches off for definitions, so I'm not going to ask on a test, but something you should know, we have something called evaporation. And evaporation is which molecules escape from the liquid phase into the gas phase. And if I were to put some water on here, and nobody touched it, and you came back in 3 days, and it was a small amount, it'd probably be gone, because the water evaporated. It became a gas. And settle down, I still got 40 seconds, and that's an important thing. And also, when you heat things up, they evaporate quicker. And we'll learn more about that. You are itching to go, so I'm going to let you out a whole 20 seconds early. I'll see you on Wednesday.